Okay, this is going to be a demonstration of a Comp429 final project. What we've created here is a application called LAN Chat, in which you're able to communicate in a peer-to-peer fashion using one simple program. The program acts as both a socket server as well as a client. Under the hood, it has a server thread running in order to continually accept new connections from other clients, as well as it has multiple threads that it can spawn off in order to make clients on its own runtime. Additionally, this should satisfy all the commands that are listed in our rubric, such as help, my IP, my port, connect, list, terminate, send, and exit. And so just perusing through the code, you can definitely see a few of the different threading calls that are going to actually facilitate connections to clients from a background server. The actual sockets and socket settings are pretty boilerplate. We're going to just continually reuse this sort of flag control setups. As well as we're going to be using the Python library in order to be able to pull our own IP from this machine. So as you can see, this is all accomplished through a singular class that handles all of the logic. So I'll go ahead and demonstrate this. And it is ultimately a very simple runtime that you can see here. So I'll go ahead and demonstrate how that works right now. Python chat.py, and then we have to initialize on one of our own local ports here as a command line argument, and immediately you're prompted with a help display. If at any point during the runtime you have these two greater than symbols next to each other, you can always type in help and receive this output again. So just for reference, you can always type in my IP, get your own IP address. And if there's no other connections or server waiting on the other side to establish a connection, it won't work. But if I were to try and say connect 192.168.0.31, which is my IP at the moment, and I want to connect to port 8000 on this IP, you're going to get a connection refused, and that's because I haven't actually started up another instance of this application. So there's no server waiting to accept connections. So if I were to do python chat.py and then wait on this port, again, you're prompted with the help display. I'm going to go ahead and try and run that command again. Connect 192.168.0.31, and let's connect to port 8000. And so immediately on both sides, you're going to see that this client got connected and this connected to a client. And so from here, a couple of things can happen. You can always type in my port to see which one you're typing or streaming into, as well as list to see all the active connections. And so if I were to send to ID of 1 a message like, hello, my name is Ben, what you'll see is immediately on the other side, you'll be receiving that. And this is two-way, of course, so I could send one to and say, nice to meet you. The character buffer that we're using here is going to be limited to 100 characters. This can be variable if you want to, but for the purpose of demonstration, I think it's ample. We don't need to send a book. Now, I've already forgotten the commands that we can use, so I'm going to go ahead and say help so that we can finish going through all of the commands. Since we already listed what addresses we have, I'm going to go ahead and terminate this connection. And now that it's terminated, you'll see that you're not going to be able to actually send a message out to this connection any longer because it's not connected. I'm sorry, we need to hit send 1, and connection 1 does not exist any longer. So from both ends, you should be able to make this connection again. 192.168.0.31, and we're going to connect to port 7999 because that is my port. Correct. Now I'll go ahead and list mine here. Get a little help message again. Terminate 2. So as you can see, the connections continually increment from 1. So we're going to never see connection 1 again, as it naturally just makes new connections over time. So now that we have all of our connections terminated, we can demonstrate that we are sending back and forth messages. I'm going ahead and on one of these ends, exit. And what's actually happening here is a signal handler is telling the program to shut down the server as well as any of the remaining connection threads that might have been spawned off during its runtime. Do the same thing here. And that is, for the most part, the way this program works. I think some of the greater challenges that were faced were trying to establish multiple connections by the means of threads. Python makes its thread interface very simple to use, but in fact, handling a bunch of connections over this socket was a little bit difficult to learn how to actually pass off this file descriptor into a thread so that it can continually talk to each other. The way we accomplished that was through a map. We were able to just simply store everything in a big dictionary, which was ideal because you can always reference the actual connection by a key, which is our numbers that increment from 1. And that's the entirety of our program. There is a README as well to demonstrate all of this, and a contributions list.